Hello, this is Mr. Kenyon Nola, and today I'm going to show you the sum of exterior angles theorem. 2 episodes ago, I taught you the sum of interior angles theorem. If you guys remember, n minus 2 times 180. N is the number of sides, n minus 2 is the number of triangles, and the 180 is the triangle sum theorem. Okay, that's a great review, huh? And the last episode, I showed you the one interior angle for a regular polygon, which is just n minus 2 times 180 divided by n. Today, I'm going to show you the sum of exterior angles theorem. Now, just pay attention. Okay, stick with me. Just join up and then hang on for this ride. I'm going to do all the heavy lifting. You just need to pay attention and it'll be all good. I'm doing the heavy lifting. You pay attention. So there are the roles for this video. You pay attention. I do the heavy lifting. Okay, so here we go. Here's a question. What is the sum of exterior angles for this square? And we're going to see a pattern here so that I'm doing the heavy lifting, and for you in the future, after you're done with this video, it'll be all good. So sum of exterior angles for this square. That means what is this angle plus this angle plus this angle plus this angle add up to? Well, we know in a square the interior angles are all 90 degrees, and if we extended each of these lines going this way, the question is, what is this angle plus this angle plus this angle plus this angle add up to? Well, if this is 90, these angles are supplementary, so this angle has to be 90. Supplementary, this angle has to be 90, this angle has to be 90, and this angle also has to be 90 degrees. So what is the sum of all 4 of these angles, you ask? Well, let's take our calculators. 90 times 4 is 360 degrees. So our answer, the sum of exterior angles, is 360 degrees. Okay, easy enough. Okay, now here's the next one. I'm going to cover it up. It says, what is the sum of exterior angles for this pentagon? And I'm not going to show you how I did it. I'm just going to show you what I did. I used this formula, n minus 2 times 180. And because this was a regular pentagon, I figured out that each of these angles using the one interior angle in a regular polygon formula was 108 degrees. So again, if you're unfamiliar with this formula, watch the previous video. But let's just label all these angles. 108 degrees. And we're going to do the same thing. Because these angles are supplementary, I'm going to figure out what each of these exterior angles are by going 180, subtracting it from 108, and it's 72 degrees. So this angle has to be 72 degrees, 72 degrees, 72 degrees, 72 degrees, 72 degrees. And the question is, what is the sum of these exterior angles? What do all 5 of these exterior angles add up to? I could type 72 plus 72 plus 72 plus 72 plus 72, or I could go 72 times 5, which turns out to be 360 degrees. Okay, so the sum of exterior angles for a pentagon is 360 degrees. Let's see if we see something, if we see a pattern. Let's use some inductive reasoning here. Look for a pattern and come to a conclusion. Well, so pentagon, what's next up in line? The hexagon. What is the sum of exterior angles for this hexagon? And it's a regular hexagon because I'm going to put tick marks here that says it's regular and all these angles are congruent. So, just like in this problem, the previous problem with the pentagon, we have to figure out what each of these interior angles are. And I did that right here. I used the same formula and I plugged in the number of sides, and I found out that each of these interior angles are 120 degrees. And because these angles are 120 degrees, they're supplementary, so we can figure out that each of these exterior angles are 60 degrees. And if we add up all 6 of these 60-degree angles or multiply it by 6, what? 360 degrees. This plus this plus this plus this plus this plus this. All 6 of these exterior angles add up. Exterior add up to 360. Okay. You might be seeing a pattern. You're like, okay, but I don't know. Will it work for the next one? Well, let's see. What comes after a hexagon? A 7-sided shape. A heptagon. 7 sides. And I did the work for you. And so every angle is about 128.5714. And our goal, figure out what this angle is. And then multiply by 7 to see what all these add up to. So I'm going to get the exact answer. So instead of just 128.5714, here's everything. And I want to take that and subtract it from 180. Well, this answer is going to be a negative number, but it's going to be a positive. So because I did 182nd. So this angle right here is 51.4285714. Positive. It's positive. And then I'm going to multiply it by 7. Ignore that negative. It's 360 degrees. So can we come up with a conclusion? Look, you don't even have to. So if you can come up with a conclusion without ever you won't ever have to do any math anymore. If you ever see a question, what is the sum of exterior angles for this? And it doesn't matter what this question, what this polygon is. It could be a decagon, it could be a nonagon, it could be a 40gon, 150gon. The answer will always be 360 degrees. So here it is, the sum of exterior angles for all polygons is always. Now, I did the heavy lifting. You will never have to do this and do this and do this and for any shape, because we can use a pattern. We can use this pattern that we just watched. They always add up to 360 degrees. There you go. What is the sum of exterior angles for whatever polygon is here? It's always 360 degrees. There you go. So just remember that. Highlight this. Put this in your notes. Don't ever forget it. The exterior angles, this plus this plus this plus this plus this plus this plus however many exterior angles is always 360. All right. Have a great day.